this is the part 2 of the review. If you haven't watched the first part, go ahead and watch the first part before coming here. Okay, so now let's consider the following question. Find the average rate of change for the function over the given interval. You have the function y equal to 3 over x minus 2 when x equals 4 and x equals 7. Now, when you say average rate, what does that mean? Average rate is just like the slope. Okay, so that's just the slope. So in other words, if you are to find the average rate, you're just going to get the change in y, so that means f of 7 minus f of 4 divided by the change in x, that is 7 minus 4. Okay, so this is your average rate. Now our f here is your function y, or your y is your function. F of x is equal to y. So this will just be 3 over, now replace the x here by 7. So that is 7 over 7 minus 2 minus f of 4 is 3 over 4 minus 2 divided by 7 minus 4 is 3. Okay, and then you simplify. So this is 3 over 5 minus 3 over 2 all over 3. Now you combine these two. The LCD is 10. So that is 10. 10, 6. So you multiply both numerator and denominator by 2 to get 10. So that is 6 over 10, and then here you would multiply both numerator and denominator by 5. So you have 15. So minus 15 over 10 divided by 3. So this is equal to negative 9 over 10 over 3. Now if you divide, remember when dividing a fraction, all you need to do is get the reciprocal of the divisor and then proceed to multiplication. So this is the same as negative 9 over 10 times, now the reciprocal of 3 is 1/3, so times 1/3. So this is equal to negative 9. Oh, and then you can simplify. Now the 9 and the 3 here has a common factor. So therefore this is equal to negative 3 over 10. That's the average rate of change for the function over the given interval. So if you go back to the problem, that is letter A. And so for the next problem, you are to find the average rate of change of the function over the given interval. Here, you are just asked to find the expression that could be used to find the average rate of change. And what is that? As I've said, that is just the slope, the change in y over the change in x. So that is letter C. F of 11 minus f of 3 divided by 11 minus 3. Okay, next problem. Suppose the position of an object moving in a straight line is given by this expression here. Find the instantaneous velocity when t is equal to 4. Now, when you say instantaneous velocity, that is an application of the derivative. So if you look at the choices here, that means you're going to use the definition of the derivative. So which of the following expressions here could be used to find the instantaneous velocity at the given time? So how do you get the instantaneous velocity? It is just the limit of the average function. Okay, so that means the limit of the slope. So which one here? Is it this or this? Now, the only thing here, okay, so this one looks correct. Like this part here is correct, but this portion here makes it incorrect because as you could see, you have B approaches A, but where is B here? Okay, so that what's make this one incorrect. So the other definition that you could also use is to have this H here. So you would have S of 4 plus H minus S of 4 over H as H approaches to 0. So letter C is the answer. So I encourage you to go and check on the definition of the derivative. And then just apply that definition to this problem here. Now for this next problem, we are to find the instantaneous rate of change for the function at the given value. Now here we are to find the value. Okay, so again, when you say instantaneous rate of change, that is just the derivative. The derivative of this function at t equal to 4. So since we already know some properties of derivatives, then we could go ahead and use them. So in this problem here, we are just going to get the derivative. So we don't need to use the limit definition to find the derivative. We're just going to use the properties of derivative. So g prime of t is just equal to derivative of 2 constant is 0. So minus the derivative of t squared, and that is just negative 2t. Then next is to evaluate it at t equals 4. So you have g prime at 4. That's equal to negative 2 times 4, and that is equal to negative 8. So the next application of the derivative or definition of the derivative is the slope of the tangent line. So in this next problem here, you are to find the equation of the tangent line to the curve when x has the given value. So that means your curve is f of x equal to x squared minus x, and x is equal to 3. So now to solve this, since we want to find the equation of the tangent line, that means we have to find first the slope of the tangent line. So the slope of the tangent line is just the derivative of the function evaluated at the given value of x. So here, let's compute for the slope m. Okay, so first let's find the derivative. So f prime of x is just equal to 2x minus 1. So the derivative of x squared is 2x, and the derivative of x is negative 1. Then, to find the slope, just evaluate the derivative at the given value of x. So at x equals 3. So this is just 2 times 3 minus 1. 2 times 3 is 6. Minus 1 is 5. So our slope is 5. Now, we will use the point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. But we only have x here. We still need to find our y sub 1 or our y value. So to do that, to get your y sub 1, you're just going to evaluate your function at the given value of x. So this is just f at 3. So you have 3 squared minus 3. 3 squared is 9. Minus 3 is 6. So y sub 1 is 6. Now going back to the formula here, we have y minus the value we got for y sub 1, which is 6, is equal to m, and our m is the slope, which is 5, times x minus, or x sub 1 is the given x value, 3. Then we simplify this. You actually go back to the choices and see that we are looking for the slope-intercept form of the line. Okay, so let's go ahead and simplify this. We have y minus 6 equal to 5x minus 15. Then you have y equal to, move negative 6 to the other side of the equation. So that's 5x. And so you have negative 15 plus 6 is equal to negative 9. So the answer is y equal to 5x minus 9. 5x minus 9. So that's letter B. In this next problem, we are asked to sketch the graph of the derivative of the function here. So the graph of the given function is given, and we are asked to graph the derivative of the function. So let's do that. Okay, so I copied it over here. So now, if we consider the graph here, this is the graph of the function, and we want to graph its derivative. So let's begin by looking at the points for which there is a horizontal tangent line. So it is this point here. If there's a horizontal tangent line, that means the slope of the derivative at that point is just 0. So we begin by plotting that. So we have at x equals 0, we have 0. So this is f prime of x, and this is your x coordinate. Now, the function is actually divided into different intervals. So it is divided into, let's look at those intervals here. We have the interval from negative, so it is up to here, so that's from negative infinity up to 2. And then we have 2 to 2. And then here, starting at this point, that is 2 to positive infinity. So we're also going to divide our graph for the derivative at these points. Now, notice that at these points here, at x equals 2, we have a discontinuity. So we have discontinuity at x equals 2. So that would imply that there's no derivative at those points. So the derivative at x equals 2, the derivative at x equals negative 2, and at x equals 2 does not exist. So there's a hole in the graph at those values of x. Now, let's consider first the function on the interval from negative infinity to negative 2. Notice that the graph of that function is a line. So it's a straight line. So we know that the derivative is the slope of the tangent line. So if it's just a line, that means the derivative is a constant. So all we need to do is find the slope of the tangent line of the function at this interval. So to do that, let's find a point here, 2 points on that 2 points on that graph, and determine the slope. So we want to find the slope at those points. So we identified this point here. That is the point negative 3, 2. And this is the point negative 4, 4. So change in y, 4 minus 2, over change in x, negative 4 minus negative 3. And so 4 minus 2, negative 4 minus negative 3. And that is equal to 2 over, this is negative 4 plus 3, so negative 1. So the answer is negative 2. So here we have the slope of our line is negative 2. So when we graph that, that means that f prime of x on those at that interval is negative 2. So we have, so for instance, this is x equals negative 2. So this, if this is 1, that's 2. Go, wait. Let's make a grid. So we will have, oops, let me just erase that. So that is negative 1, so this is negative 1, negative 2. So this would be the f prime of x is negative 2, so it's just a constant. Now there should be a hole at x equals negative 2. So that's the graph at that point. Next, or on that interval. So next, let's consider this interval here from negative 2 to 0, because we know that at 0, this is at x equals 0, the derivative of the function is also 0. We have a horizontal tangent line here. So from here, we know that our curve is increasing. Our curve is increasing. That means the slope is positive. So between negative 2 and 0, the slope is positive. That means we expect our graph to be above the x-axis. We expect the graph of f prime of x to be above the x-axis. So somewhere above here. And we know that the slope is positive and it is approaching to 0. So it will approach here. Now, but we want to know where it would start. So to do that, we will have to approximate the slope of the tangent line at this point. So we want to approximate the slope of the tangent line at that point. Now, so this is just an approximation. So we have this point here. So we consider that point. That point is the point, say, negative 2, negative 3.25. And then let's find another point here. This would be the point, word ordered pair, negative 1.75 and negative 2. The y-coordinate is negative 2. And so we get the slope of that line. So here we have the black one. It is equal to the change in y. So that's negative 3.25 minus negative 2 over the change in x. So negative 2 minus negative 1.75. And this is equal to negative 1.25 in the numerator, and in the denominator it is negative 0.25. So let's divide that. That should be positive. Okay, so let me go ahead and divide that. So I have negative 1.25 divided by negative 0.25 is approximately 5. Okay, so we have approximately 5. So that means, so this is equal to 5. So that means that we would have to start at y equals 5. So when x is equal to negative 2, y or f prime of x is 5. So you have 1, 2, 3, 4, 5. Now that is x equals 2. And there should be an open hole here because the derivative does not exist at x equals negative 2. And so the graph would look like this. The slope eventually approaches to 0. There we go. And use the same, so it's above the x-axis because you know it's positive, it's increasing. Now if you look at the interval from 0 to 2, you also notice that the curve is also increasing. So that means we expect our curve to also be positive. And similarly, we get those 2 points here. We get 2 points on the curve and approximate the slope of the function at this point. Okay, so I think that is just this point here would also be 3. That would be 2. The point of the coordinate is 2, 3.25, and then another point here that will be 1.75, 2. And then when you get this, when you get the difference or the slope, you also get 5. So at x equals 2, 1, 2, at x equals 2, you have f prime of x is equal to 5, and there's a hole there because the derivative does not exist at x equals 2. And it's above the x-axis because the slope here is positive, or the function is increasing on that interval. Then lastly, let's get the slope of the line here to get the graph of the derivative on the interval 2 to positive infinity. So we do that by considering the point here and this point. So this is 2, this is 2, 0, and this is the point 3, 1. And then you get the difference. You get the slope. So the slope here, m, is equal to the change in y, so 1 minus 0, over the change in x, 3 minus 2. And that is equal to 1 over 1, and that's equal to 1. So that means that the slope is equal to 1. So at x is equal to 2, so again, open hole at 2, and then on the interval from 2 to positive infinity, the derivative is just equal to 1. So this represents the graph of the derivative of the function here. All right, let's consider this question here. We are asked to find the derivative of this function. Okay, so now to find the derivative of this, we will have to write this in a form that we already know what the derivative is. So in a form where we have actually a formula. So it looks like we would need to write this of the form cx to the n, because we know that the derivative with respect to x of cx to the n is just equal to c n to the x to the n minus 1. So cn times x to the n minus 1. So to do that, we will have to rewrite f of x as 4. Now this denominator, if you have a square root, that means that you could write this in exponential form where the exponent is a fraction. So the denominator, square root of x, could be written as x to the 1/2 minus, now here we'll just write that as x of 8 over x, and then you just copy 8 over x to the 4th. Now also recall that if you have 1 over x to the n, you can also write this, or this is also equivalent to x to the negative n. So that means we could bring this expression in the numerator. So we could write that as 4x to the, now we would change the power to negative. So if you have 1 over x to the n, that is just x to the negative n. So this will be x to the negative 1/2 minus 8 x to the, what's the power of x here? Power of x here is 1. So x to the negative 1 plus 8x to the 4 becomes negative 4 to the negative 4. Now that we're able to rewrite our f of x in terms of cx to the n, or in the form of cx to the n, then we're now ready to differentiate this. So applying this formula here to the expression here, we have 4 times negative 1/2. So you bring down the exponent, and then copy the base, which is x, and then subtract 1 from the exponent. And you do the same thing on all terms. So for the second term, we have 8, bring down negative 1, copy x, and then subtract 1 from negative 1. Then similarly, for the third term, we will have 8, copy 8, bring down negative 4, so negative 4, x to the negative 4, and then subtract 1. Now, let's simplify. So this becomes 4 times negative 1/2 is negative 2, x to the, now negative 1/2 minus 1 is negative 3/2. Now negative 8 times negative 1 is positive 8. X to the negative 1 minus 1 is negative 2. And then 8 times negative 4 is negative 32. X to the negative 4 minus 1 is negative 5. Now, if you look at the choices, they're all written in, like they all have positive exponents. So that means we can have, the next step is to bring this down again. So we will have negative 2 over x to the positive 3/2 plus 8 over x squared minus 32 over x to the 5th. And that's the answer. That's the derivative. Okay. So negative 2, again, negative 2, positive 8. Negative 2, positive 8 minus 32 over 5. So letter D. Now let's proceed to the second, or the next question. Find the derivative of the given function here. So if you look at this, you can use the quotient rule, or you can just rewrite the function and apply the basic formula on the derivative of exponential functions. Okay, so let's just use the basic one. So what we could do is we could rewrite this function as x over square root of x plus 7 over square root of x. Then then you simplify. So you have x over square root of x is just square root of x. And then plus 7 over square root of x. Now we can write this in exponential form. So you have x to the 1/2 plus 7 over x to the 1/2. Then we could write this as x to the 1/2, and then 7 over x to the 1/2 can be written as 7x to the negative 1/2. That's your f of x. Then you differentiate. So what's the derivative? F prime of x is equal to the derivative of x. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. So that's negative 1, 1/2 minus 1. So that's negative 1/2 plus 7 times negative 1/2, bring that down, and then subtract 1 from negative 1/2. That gives you negative 3/2. And then if you are, let's look at here. Okay, so this is a multiple choice question, so that means you would have to write it in this format here. So we have x to the 3/2, and then if there's a square root, you'll just have to bring that down. So let's simplify this. Okay, so this one is just 1/2. Now you bring this down to make it positive, so that's x to the 1/2 minus 7/2. So 7 times negative 1/2 is negative 7/2. And then you have x to the positive 3/2. So if you bring down, if you write this in the denominator, the exponent becomes positive. And then now you could write this as 1/2 square root of x minus 1/2 square root of x cubed, square root of x cubed. And so 1/2. Oh, I guess we have a different problem than what I was looking for, because this is 7 and the other one was 5. Okay, so that should be the answer. Now let's look at another example where we could just simplify the function rather than applying the quotient rule. So in this case here, because the denominator is just composed of a single term, then we can just divide each term in the numerator by x squared. Okay, so let's have this one becomes, okay, hold on. This is equal to x to the 4th. So you divide x to the 6th by x squared. That is equal to x to the 4th. And then plus 7/x squared. Then write this as x to the 4th plus 7x to the negative 2. Then you can differentiate. Y prime is equal to 4x cubed plus 7 times negative 2x to the negative 3. So this is equal to 4x cubed minus 14/x cubed. Okay, next item. Find the derivative of the function evaluated at -4 if f of x is equal to x to the 4th over 8 minus 7x. So this one means that you have to find first the derivative of the function. Then once you have that, you evaluate it at x equals -4. So to do that, we will have to first find f prime of x. And this is equal to 4. You differentiate x to the 4th, and that's 4x cubed over 8. Minus, copies -7, and then differentiate x, which is just equal to 1. Then you simplify that. You can cancel 4 here. You have x cubed over 2 minus 7. The next, evaluate the derivative at x equals -4. So you have -4 cubed over 2 minus 7. And then simplify this. Okay, so -4 quantity cube is just equal to -64. Divided by 2 is -32. So you have -32 minus 7 is -39. Now in this next problem, we are asked to find all values of x where the tangent line is horizontal. So when you say tangent line is horizontal, that means that the slope of the tangent line is 0. So in other words, to find that x, all you need to do is find the derivative of this function and then set it equal to 0 and then solve for x. Okay, so to do that, let's find the derivative of the function first, f prime of x. That is equal to 6x squared plus 90x plus 324. And then now equate this to 0. You solve for x. Now check, is 90 divisible by 6? Yes, that's equal to 15. What about 324? Is that divisible by 6? 324 divided by 6 is 54. So that means we could divide each term here by 6, including that 0. This could be reduced to x squared plus 15x plus 54 equal to 0. And then now you factor. Okay, so let's look at the factors of 54. And 54 is 9 times 6. And if you add 9 and 6, that gives you 15. So that means that you could factor this into x plus 9 times x plus 6 equal to 0. So x, equate each factor to 0 and solve for x. That's why you have x equals -9 or x equal to -6. These are all the values of x for which the tangent line is horizontal. Again, when you say tangent line is horizontal, the derivative is equal to 0. Okay, so next problem. We are asked to use the product rule to find the derivative of the following function. Okay, so let's just go ahead and apply the formula for the product rule. So recall, product rule is that the derivative of u and v are functions in x. The derivative of uv is equal to uv prime plus vu prime. So here, y prime is just equal to u, so you copy x plus 5, and then you differentiate 7 square root of x plus 5. Okay, you differentiate that. And then plus, you copy 7 square root of x plus 5, and then you differentiate x plus 5. All right, so now let's perform the derivative. So this is like your u, and that's the v prime, and this is v, and that's the u prime. Okay, so now you have u, copy x plus 5, and then differentiate. So what's the derivative of 7 square root of x? Whenever you see square root of x, think of this as x to the 1/2. So that when you differentiate this, the derivative with respect to x of square root of x, that is just equal to 1/2 x to the -1/2. So that means 1/2 square root of x. Go ahead and memorize that, because that usually comes out. Okay, so the derivative here is that copy 7, and the derivative of square root of x, the derivative of square root of x is just 1/2 square root of x. And then the derivative of 5 is 0. And next you copy plus 7 square root of x plus 5. And then you differentiate x plus 5, and that's just equal to 1. The derivative of x is 1. Okay, now, did you know that you could input your answer like this? You don't need to simplify this. If it's like that, if it doesn't mention that you need to simplify it, you may input your answer like this. Okay, now for quotient rule. For quotient rule, you will have to use the formula. Let's just look at another problem, okay? So here, let's use quotient rule to find the derivative of this function here. Okay, so what's the formula for the quotient rule? So if you have a function u over v, you want to find the derivative, this is just equal to low, so v, the high, u prime, minus high, so u, the low, derivative of the denominator, v prime, all over low squared. Okay, so you could also use that mnemonic, low, the high, minus high, the low, all over low squared. So your numerator is your high and the denominator is your low. Okay, so now applying that formula to the function here to find the derivative y prime, you just have low, so you copy the denominator, 7t plus 2, low, d high, derivative of the numerator, derivative of 3t minus 4 is 3. Low, d high, minus high, so copy numerator, 3t minus 4, d low. Derivative of the denominator is 7. All over low squared, 7t plus 2 squared. Remember, you can input your answer like this if it did not specify that you have to simplify it. However, for the sake of illustration, we're going to simplify this. So to simplify this, you would have to distribute to each term in the parentheses the 3 here. So you distribute that to each term in the parentheses. So that gives you 21t plus 6 minus, let's put a parenthesis here. You distribute 7 to each term in the parenthesis, and that's equal to 21t minus 28. All over, just copy, no need to expand. 7t plus 2 quantity squared, just a numerator. And then we have here 21t minus 21t, that is just 0. And then 6 minus negative 28, that makes it positive 28. So positive 28 plus 6 is 34. So you have 34 over 7t plus 2 quantity squared. That's the derivative of the given function.